4 matrices. So what's a matrix? Well, it's just basically putting a bunch of numbers in a box. And we get to change our words around this time. So we don't just call them numbers in a box, even though that's what they are. Instead of using the word numbers, we use the word elements, which basically means the same thing as numbers. We're going to learn about 8 different words for numbers in this unit. Okay? And making a rectangle has rows and columns. Do you know the difference between a row and a column? 3, 2, 1, 5, 8, and -3. That would be a matrix. How many rows does this matrix have? How many columns does it have? Okay? So these are the columns, because if you think of trying to support a roof with columns, it doesn't make sense to have them go sideways, unless you have a lot of them, but then you probably can't get into your house. So the columns are the ones that go up and down. This one has 3 columns and it has 2 rows. And we use square brackets. Sometimes I've seen round brackets that are smooth, kind of like that, but we'll draw them with square brackets. And we can do a bunch of math with numbers inside. You can even put variables in there. It's just a way of holding numbers in a certain position. Okay? And that's why matrices are used. It's to organize data. And the reason it's efficient is because you can just write a number in a specific spot, and then you don't have to put x's with it or y's with it when you're solving equations. Or if it represents something, you don't have to say that that was 3 cats and 2 dogs equals 1 elephant, if that was your equation to start off with. All right. And maybe that would be true if it was values of like sculptures. Cat sculptures were tiny, dog sculptures were a little bigger, and the elephant sculpture was really big. So buying 3 little cat sculptures and 2 dog sculptures would cost you the same as 1 big elephant sculpture. So that maybe could be an equation. And then the reason we're connected to solving systems of equations is then you can use this to solve it. This might be a way of writing 3x plus 2y equals 1 and 5x plus 8y equals -3. And that would be the matrix that you could use to represent that. Notice, since you know that the first column was x's, you don't have to write x's down, saving you valuable time while solving it, supposedly. So those horizontal entries are rows, and the vertical entries are columns. And we say the dimensions of a matrix, just like we would say the dimensions of a rectangle are one side by another side. And we would say m by n. We always do rows first and then columns. And the easy way to remember this, and I've got it in your notes right there, right? Matrices rock. And if you think matrices rock, you will remember rows first. And then depending if you have a Russian or an English spelling of columns, it could be C or K, or you could just pronounce it columns, maybe like that. And then you have matrices rock. And it's easy to remember that it's rows by columns. Yes?
You know that this makes no sense because you're always using x first and then y, and now you're using y first and then.
It is what it is. So we do our rows first and then our columns. So here's a matrix that is a 3 by 4 because it has 3 rows and 4 columns. And then you got your rock right there to help you remember. So we call the size or the order of the matrix by its dimensions. So there are 3 by 4 matrices, 2 by 4 matrices, 1 by 1. It's a really tiny matrix. And that is the size or the order of it. So basically asking the order is basically asking the dimensions. How big is that first one? It's a 3 by 1. We don't actually multiply it out. We write it actually as this by this. Okay? If you would multiply it out, though, 3 by 1, 3 times 1 is 3, and that tells you how many elements you have in that matrix. Okay, this one has what by what? 4 by 3, and finally 1 by 4. We use capital letters for all our matrices. And when we're talking about the little elements within, we use small letters. And we itemize them by which row and which column. So sometimes you'll see things written with a comma in between. Sometimes they won't write that comma in between if it's a small enough matrix. So here's some examples. Here's with the comma in there, 1, 1, 2, 2, 3, 3, being the main diagonal. But you could also write it without the comma. That would mean when the matrix isn't very big, because then you wouldn't have to tell, you know, if you had 313, you wouldn't know if it was 3 and 13 or 31 and 3. So then the comma helps you see that. But if it's small enough, then when you write 2, 2, you know that it's row 2, column 2. And so this, with all of these elements being small a's, we would call the matrix with a big A. If you called the matrix with a big B, all the elements, you would have little b's to represent it. So take a look at that matrix and quickly write down the values that correspond. Did you get 0 for the first one? And 3, 4. Whoa. E. And 2 for pi. And what's the order of this one? There are 3 rows and 4 columns.